get cracking, and I have lots of pictures in here, so hopefully that will help. So I've been looking at global offshore wind from more like a business market point of view. I'm not an engineer, so if I look at the projects, you have a much better idea what you think technically makes sense or doesn't make sense. I just look at what's happening around the world, who does what, why, who's financing stuff, what are the key drivers. So I was also given a title for a presentation, plus I was told I could only have 15 slides, so this is quite condensed. So again, we have right now, this is the list of the operating projects that we have in the world. We don't need to talk about high wind and principal power, we all know that. Again, I think most people in this room do know by now the Japanese projects. So, but what you see here, you have basically, right now they're installing these Mitsubishi Semi-Submersible. So starting 2013, you suddenly have Japan being big time on the map. And it caught, I think, a lot of people by surprise, especially in Europe. If you actually looked at a lot of Japanese publications in the last several years, you find that it goes 10, 15 years back that they started researching on floating substructures. And there was a number of reasons for that. First of all, Japan always looks, what's happening in the world. They saw the Europeans doing offshore wind and said, oh, let's look into this. Obviously, the conditions in Japan are deep water, so it was very clear that has to be floating. You're also dealing with a major shipbuilding nation, yeah. So it's something actually that's in a way a given for Japan to look into this sector. Then obviously in March 2011, the Fukushima nuclear disaster, the tsunami and earthquake totally changed the landscape here because Japan basically went from 54 nuclear reactors running to basically 0 running within a few months. And it has basically caused a major, major review of Japanese energy policy, which is ongoing. There's power market reform going on, I think. Renewable energy plays a role in this, and definitely floating offshore wind plays a role with this from an energy but also an industrial perspective. So if we look at Japan, where these projects, you basically have the Kawashima spar off an island near Nagasaki, and then you have the Fukushima forward project, basically off the coast of Iwaki, which is actually in Fukushima Prefecture. That is not far from that nuclear reactor. You also have impact of, depending on what's going on, seawaters with certain levels of radiation and all of that stuff. If you look at this map, just look where Nagasaki is. The Mitsubishi Semi-Submersible substructure was built at Nagasaki. The Mitsubishi shipyard in Nagasaki was towed all the way from there up to the Fukushima coast last November. That's a long way. And I'm pretty sure they don't want to do this long term. They had originally planned to install that semi-sub with the 7-megawatt Mitsubishi hydraulic turbine last November. They delayed it until this summer, not because there was an issue with substructure, but because issues with the turbine. Power curve issues they had to fix. If you go actually, what was the first full-scale project in Japan, that is what I always call the Kawashima Island Spa, because it's off Kawashima Island in Kyushu. Very systematic approach with their 1/10 scale, then half scale, which they operated for a year, and then the full scale. That was, both of these were installed with a massive floating crane. If you look at the images, it's very interesting. If you look at Japanese supply chain, it exists for all types of civil engineering projects, especially bridge building and all of that. So the floating cranes that they have are mostly also for bridge and other construction projects, and have now being used for the emerging offshore wind industry. On this project, this has a concrete, basically pre-stressed concrete component that was developed by Kyoto University. And that's also why, compared to the other projects you have with Toda Construction, actually a normal civil engineering construction company in the consortium and not your typical shipbuilder. And this project is 100% financed by the Japanese Ministry of the Environment. That has a number of reasons, that though the major reason also runs, or basically applies to the Fukushima project. Japanese fishing industry is one reason why Japan didn't have installed offshore wind power. The fishing industry in Japan is very, very powerful, and they have for many years blocked any development in this area. After Fukushima, they realized, okay, you know, nuclear power is not the answer because you can't fish in certain areas. So they started to be more open, and with this project by the Ministry of Environment, the Japanese government and industry is trying to work with the fishing industry and sort of deal with some of the pushback, and to show that offshore wind and fishing industry can coexist. The Fukushima Forward project, again, the phase 1 has been operating since November 2013, and again, only in November 2011 the Japanese died, so the Japanese Congress confirmed the budget for this project. 2 years later they had the first steel in the water, not without bumps in the road, but hey, they've done it. Among this is the first floating substation, which is the Hitachi substation on a floating spar developed by Japan Marine United. And then part 1 of phase 2 is in commissioning as we speak with the Mitsubishi Foundation. This project is also funded 100% by the Japanese government, but in this case by the Japanese Ministry of Economy, Trade and Industry, which is probably the most powerful Japanese government agency out there. And again, it's a combination of a number of things. It's getting industry to work together to make these pilot projects happen. At the same time, yeah, working with the fishing industry, getting the fishing industry on board and familiar with this technology. Another industrial sector that is not very keen on floating offshore wind or offshore wind in general is the marine logistics industry. Japan has a lot of their domestic transportation of goods along their coast with coastal vessels. For example, Toyota buys parts out of Tohoku and they have to go to the Nagoya area. They, in many cases, do not go by truck. They go by coastal vessels. And therefore, the coastal logistics industry in Japan is also very powerful. And they are pushing, for example, also the government. There's a project ongoing right now about navigational standards. Yeah, how does offshore wind impact navigational rules for coastal vessels? What about potential collisions? Yeah, what about seaquakes, typhoons, and all of this? So there's a lot of other aspects in these Japanese projects that the government is trying to address with this. What's also interesting about the Fukushima project is the specific transmission development. So the 66 kV riser cable and the 22 kV riser cable were specifically developed for this project by, among us, Furukawa Electric. There is now the next generation riser cable that's under development basically for larger commercial projects. So it's again a sign that they're basically trying to sort of cross off all parts here. So I find when I look at a lot of the Japanese language literature on these projects, there's a lot about transmission and again how you connect it within the array and to the shore, and a lot of R&D. So what does this look like? So this is the Mitsubishi Semi-Submersible that was built at Mitsubi's shipyard in Chiba. It also shows you that long-term fabricating this in shipyards is not the answer, because I mean this is a substructure. Okay, there's a lot of redundancy, but in a shipyard you scale that up and it will no longer fit. So there's one supply chain challenge that has to be addressed right there. Again, there's a lot of redundancy in the structure because it's huge for a 2 megawatt turbine. Mitsui also confirmed that. But obviously nobody wants this system to fail, but they will be the first one to tell you this is way too expensive. The other interesting part to this one, Mitsui had also developed a TLP, and they were pushing very, very hard to build a TLP as part of the Fukushima Forward 1. But it was academia and the government who basically said, no, you're going to build a semi-sub. And again, who pays? In this case, the Japanese government, who pays in the end decides what's going to be built. The reason for that is that, especially on the Japanese academia side, there's a lot of concern regarding TLPs with regard to sea quakes, and especially what anchoring systems on TLPs, you know, they see that as a high risk of potential failure in case of sea quakes. So that's why academia basically pushed back and convinced the Japanese government that Mitsubishi should build the semi-sub and not the TLP. That gives you some of the dimensional information of the turbine. Installed in there is a Hitachi 2.0 downwind turbine that's based on a Fuji Subaru. For those who may not be aware, about 2.5 years ago, Hitachi bought Fuji Subaru's turbine business and with it all the technology. And this is basically also the same turbine that's on the Kabashima spar. Hitachi is right now finalizing their new 5 megawatt offshore wind turbine, which is also downwind turbine. This is the Japan Marine United spar, and again, this is right now being used for the floating substation. In 2016, 2017, that will also be used with a turbine. Right now, the official plan is to also put a 7 megawatt Mitsubishi turbine on top of that. Personally, I wouldn't be surprised if a 5 megawatt Hitachi goes on top instead, but we will see. We actually, Walt, Amy, Steve, and I, actually, we couldn't go out to the actual site, but we actually went to the control center last fall, which was also very interesting. And they also explained, so integrated in the substation is also like an emergency living quarter. So if they had a technician out there and they couldn't get that person back, you know, because the helicopter can't, you know, operate because of weather, so you can actually, somebody can live or survive out there a few days. And this was built in Japan Marine United's yard in Yokohama. This is the Mitsubishi Semi-Submersible. Again, the substructure was built in the Nagasaki yard that Mitsubishi owns and then towed all the way up the coast, and then at Onahama outside Iwaki, put together, towed out, and again, it's going through commissioning right now. So what you have with all these 3 projects, all they have in common is you have major shipbuilders being the fabricators. And again, this tells you another thing about the objective that the Japanese government has. The Japanese shipbuilding industry has been, over the last years, been taken to the cleaners by the Chinese, the Koreans, and the Indonesians. So the government, together with industry, views floating offshore as a way to try to, again, reinvigorate the shipbuilding industry. So as much as we might say, okay, you know, let's open up different types of fabrication, from a government point of view, this is a prime example how something's being developed because to save either sector or reinvigorate the sector to create jobs. That's a fact that I think we have to accept. Moving on, what else is going on? And again, I've just looked at the projects that really have something actual going on. There is the Gikon TLP currently under in fabrication in Germany, which will be with a 2 megawatt class turbine. And then I think among the European projects, the ones that are, I think, very likely to happen is the Ideol project in France, which actually starts construction apparently in November this year. This will have a 2 megawatt turbine, though I don't know which OEM because there's been some changes. And then Ideol, interestingly enough, also has a project with Hitachi Zosen, which is also Hitachi Shipbuilding in Japan, where right now the design study is also funded by the Japanese government. And then obviously the DC and SC Reed project as well, and then obviously Hywind Scotland. The Inflow project, which was Technips and Nanoforce project, that keeps changing, and based on what I hear, you know, I don't know how, if and how that's really gonna, at least in the near future going forward. So the Gikon SOF or Gikon TLP, this is basically what it looks like. It gives you some images of the currently ongoing fabrication in Stralsund. There's been a lot of work based on all types of tank tests as well as simulation to get the actual substructure weight down to 742 tons. That is actually also, again, some redundancy built in for serial production for a 2 megawatt class turbine. It will probably be more about like 600, 650 tons. And if you want to look this up, if you go on the site listed there, you can see, you know, impressions from the tank tests and other videos. The plan is to basically install this and commission it in the second quarter of 2016, and it will be installed as part of the existing Baltic 1 wind park in the German Baltic Sea. Has a number of advantages. So obviously, you can connect to the existing grid structure and everything, but also you're going to have basically a floating turbine as part of a commercial wind farm which uses the same turbine, basically Siemens 2.3. So there's a lot of a potential to compare data and performance and everything. This is sorry, this might be a bit too small print, but so EDOL basically right now has 3 projects. So obviously the FloatGAN project in Europe. So that is also heavily co-funded by the European Commission. And there's some, apart from EDOL, some other European entities involved in this project. And then what they call the Japan project, which is, and again, it's very interesting. Obviously, if you talk to EDOL, they'll tell you, yes, this is going ahead and the Japanese government is going to fund construction. If you talk to some other people, including their competitors, they'll say, well, right now, the Japanese government is funding 2 projects for design study, and then based on especially anticipated cost, they will pick one. So the EDOL is part of the Marubeni team, which Marubeni is also the project management company for the Fukushima Forward. And then there's the Renova team, and basically as part of the Renova team is Mitsui as basically a competing technology provider. So I think it's going to be very interesting what's going to happen on that front. Said all high wind, only to say, you know, I think we all heard about the innovation challenge. When guys were in Japan last fall, we actually met with MODEC, and they actually shared with us what they had developed, and we're going to submit to high wind. It was very interesting because the MODEC concept basically uses existing vessels that transport bridge posts. So it's special vessels for bridge construction, and they sort of designed it in a way so it could be used for installing the lower part of a floating spar, and therefore get around some of the upending issue there. And then there's Disingnes Sea-Reed. I mean, this used to be known as the Nascent Wind project. That's when it started, has changed hand, and the consortium has changed a lot right now. It's basically DCNS, which is a French shipbuilder and also defense contractor, and obviously Alstom as the turbine OEM. And that's basically it. So it's the overview. And again, my key points would be, sorry what I said earlier, who pays for something has a big say in what's getting developed. I mean, we've seen it on onshore wind, we continue to see it on onshore wind, and I'm afraid it's the same with offshore wind. So while maybe some technologies may be better, if the entity or the investor that spends the money pays for it, they'll have the last say. And I think that's a reality we have to accept, and it's probably something we need to think about as part of our report, how we sort of address that. Thanks a lot. It's being commissioned on land right now. I think the plan is that it's fully certified and everything by end of this year. And they want to start offering it, to the commercial market, including, non-floating projects, basically starting 2016. That's their timeline, and based on what I know, that they're on target with that.
Were you able to get any details on that? Were they able to reduce the cell weight, or I mean, you thought maybe they might be able to actually substitute that for the Mitsubishi 7 megawatt?
No, the plan was if Mitsubishi had not been able to put their own turbine on that, yeah, they would have put Vestas on there. They wouldn't have, yeah. the
164.
yeah. Part of the issue, let's face it, it's cultural. Yeah, like on land, you have the Japanese agricultural industry. They own the land. They have a lot of power with the government. On sea, you have the fishing industry. It's basically, you know, it's sort of, we own the ocean, you know, anybody else, okay, we might put up with some vessels. So it's basically, it's a lot to do with, they just don't want the, what you call it, the mendokusai, yeah, to deal with that. You may not be able to fish here, or some areas maybe, you know, off limits. And again, what has changed that, yeah, was the Fukushima disaster, because even right now, yeah, you can imagine this entire coast here is closed for fishing. These fishermen basically right now have nothing to do.